Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the set mismatch problem. If you're seeing this, I'm on holiday at the moment and this was pre-recorded earlier. So don't worry, I've got some content hopefully lined up so YouTube realizes I'm not completely dead. Anyway, diving right in. You have a set of integers s, which originally contains all the numbers from 1 to n. Unfortunately, due to some error, one of the numbers in S got duplicated to another number in the set, which results in repetition of one number and loss of another number. You are given an integer array nums representing the data status of this set after the error. Find the number that occurs twice and the number that is missing and return them in the form of an array. So one thing it doesn't specify is what order they have to be returned in. The examples both show sorted, so I assume that's probably true. My immediate thought here, now, if you're a fan of Sudoku problems, you might have heard of Simon from Cracking the Cryptic talk about his secret. Now, I'm not sure I'm at liberty to reveal his particular secret, but I can talk about a very closely related secret. And that is a secret about the numbers from 1 to n. There's a very famous Leetcode style problem, which is if you're given the numbers, a set of numbers from 1 to n, but one of the numbers is missing, how can you find out which number that is? And the trick here is that you know what the set of numbers from 1 to n adds up to. So if I have the set of numbers 1 through to 1, well, that's just 1. If I have the numbers 1 to 2, that's 1 plus 2, which is 3. If I have the set of numbers 1 through 4, in this case, they should add up to 10. So if one of those numbers was missing, all I need to do is add up the numbers that I did receive. So say I received 1, 2, and 4. That's 4, 5, 6, 7. And I know they should add up to 10. So the number that I'm missing is 3. I'm wondering if we can use a similar trick here. I should finish that previous thought, because the numbers from 1 through to n, in the general case, they sum up to n times n plus 1 divided by 2. So if you had 1 through 9, for example, it's 9 times 10, which is 90, divided by 2, which is the secret. Now, numbers here isn't just missing something, it's missing something and had one of the previous numbers duplicated. So can we do a similar trick? So here, for example, the sum is 4, 8, 9. The sum is 9 and it should be 10. That doesn't tell me what the missing number is. So I can't just immediately apply the same trick, because I know I'm 1 short. I know the number that's been duplicated is 1 less than the number that is missing. But that could be, I have a 1, 1, 3, 4, for example. That's 4, 5, 6, 7, 8, 9. That's the same thing. 1, 1, 3, 4 has an identical sum to this. But if instead of what I could do is I could compute the sum of the set, because this would immediately tell me what number is missing. So if I have num set is the set of numbers, expected sum is equal to, hang on, let's do n is len nums. Expected sum is n times n plus 1 divided by 2. Here I'm using integer division in Python because I want to get an integer, and this is safe. I'm integer dividing by 2, and that gives me the correct result if the number I'm dividing by is even. Now, if n is even, then n times n plus 1 is even, but if n is odd, n plus 1 is even, so n times n plus 1 is even. So this is safe. The set sum is the sum of num set. So missing is expected sum minus set sum. The num sum, let me just move that down here. The num sum is the sum of nums. So here we said that was 9. We know the expected sum was 10. And that tells us where, in fact, let's do num sum minus expected sum. That tells us we've got a -1. Missing minus that difference is the duped value. So here the idea is that num sum minus expected sum, this is 9 minus 10, which is -1. Our duplicated value is 1 less than the missing value. So missing value minus -1. No, sorry, I want that to be a plus, don't I? I want that to be a plus. The missing value, 3. Add on the mismatch. So the hang on, what did I say here? The num sum 9 minus 10, this is -1, so the duped value is 1 less than the missing value. So missing -1 is the duped value. So then what I want to do is return the duped value and then the missing value. Yeah, the number that occurs twice and the number that is missing. So that is the order I want to return them. Oh, so here it looks like that. They are, it's sorted, but I think if this was 1, 3, 3, 4, I would expect to do a 3, 2 return. Yeah, otherwise it's ambiguous. So here, obviously, we want to do the 1, 1 test case, but I also want to do a 1, 3, 3, 4 test case just to see what will happen. Yeah, 3, 2. Not 2, 3. Okay. Let's see if we can tidy this. Set sum, we only use once, so that is the sum of the set of numbers. So I no longer use set sum at all. Do I use num set at all? No, I do not. Num sum is only used there, so this can be sum of nums. Expected sum is used twice, so that's worth factoring out. Missing is used twice, that's worth factoring out. N is used twice, so that's worth factoring out. I think this is quite a nice little solution here. So by changing these, I did remove some potentially useful naming, but it's so short and so simple that I don't think I actually miss anything. Because here, this is a famous result. Here, obviously this is the actual sum, quite explicitly. It's the sum of the numbers we were given. So I think that's an improvement. Anyway, let's submit it. I haven't actually tested it. I haven't actually shown this is a great solution yet. There we go. Could we have done that better? Well, I guess some of this is unnecessary. If we had combined these, here I need to traverse numbers several times for the length is order 1 in Python. But this sum and set and this other sum business is basically that there's a lot of repeated work here. We could improve this by doing a little loop up the top that maintains the num set and also the set sum and the total sum. We could loop through numbers just once, building all of these in one go. Obviously, we don't need this one in the end, but we need it to correctly maintain the set sum. So we could potentially save a couple of traversals that way, but again, easy problem. We don't need to do too much. Anyway, that will do it today, I believe. Thank you very much for watching, and do remember to like, comment, subscribe, all that good stuff, particularly while I'm away, so YouTube remembers that I still exist. Thank you so much, and I will see you next time. Bye.